Hey everyone, Alec here. I've shown individual machines on previous videos, but I've realised never actually the entire shop in a wider context, specifically the line shafting, how it all works, what kind of building it is. So I'm going to do a bit of a shop tour. We'll start out here. This beam above me is my gantry outside, and that runs through the entire shop, and is what the line shaft hangs on. And it's running at the moment because I'm doing some drilling, so let's go and have a look. So starting with the power source, as you can probably tell, it is electric, and up there is a 10 horsepower 3-phase motor which runs via a lathe shaft to get the speed down, and then down through the ceiling onto this main drive pulley, which then goes on to drive the rest of the shaft in all the way through the shed. So following it down now, we're going to start at the back, and I'll leave it off so you can hear me and I can hear myself think. The shaft comes down here and drives a little bench grinder. Nothing too interesting about that, but obviously very handy. Moving over, I have a Rapidor hacksaw, which is currently out of service because it's a bit knackered. I've got two more outside, which I'm gonna conjoin with this one to create one decent saw. So that's one project. Keep a tally if you like, because there'll be a lot of those. You probably be bingo. I've got fly press and forge. The forge is an ordinary coal forge, nothing too special about that, but it does have a interesting blower mechanism which was shop made, and it's actually a CVT variable speed drive, so it's belt driven from a small motor on the floor, and I have two opposing cones and I can shift the belt backwards and forwards, so that is quite cool. I got fed up with electronic speed controllers. So coming towards the rest of the shop, I've got the ring rollers, which I have an entire video dedicated to the restoration of those. They are driven from the same 90-degree shaft, which you can just see over there, which was driving the drill a second ago, and then there's a long belt which comes right over to the counter shaft here and driving the rolls below it. Super handy machine, probably about 1930s, so I did a lot of work to get these to the condition they're in, so it's go and have a look at that video if you haven't seen it already. There's the crane I've been working on, which I haven't had time to work on recently. I've been extremely busy with work, so that is waiting. Next up is the Drummond, which again you've probably seen on previous videos if you've been watching my channel. Now this is an interesting machine in that it's a war finish machine, so date of manufacture is 1916 according to the plate, and Drummond were taken over by the War Department soon after the outbreak of the First World War to produce lathes for the war effort, and famously were working on lathes that were self-contained motor drive to work in the battlefield machine shops, which were built into the back of lorries. It was this make of lathe that they decided to convert into self-contained motor, and they had a motor bolted on the back here with a big gear drive and a belt, and the motor ran off of the truck's alternator. So coming up to the countershaft for it, it is got its original reversible countershaft. So we have a cross belt and an open belt, and they can be shifted to the fast pulley, which is the driving pulley. That's the one that spins. These two are loose pulleys or idlers, and by shifting this handle backwards and forwards, I can move the belts left to right and consequently reverse the machine if I wanted to. This is my Jones & Shipman 20-inch pillar drill. It's got 4-speed cone pulley and a power feed as well. So that is gear driven from the top of the quill through a 3-speed box, which is adjustable by moving this selector up and down. And that comes down to a set of mitre gears and a worm wheel, which then drives the rack and pinion. And I was just working on my fly press bolster, just drilling some counter bores so the fixing bolts sit flush. I've actually gone a little too far there, but that doesn't matter. Trouble with filming things. Now the drill's driven from the same 90-degree shaft. This is the same 90-degree shaft that chucks a belt over to the ring rollers over there, and the drive belt for the drill comes down the back. And I don't know if you can see, it's a bit crowded, but there is a foot shifter there which shifts the belt from the tight to the loose and vice versa on the Jones & Shipman. The Jones & Shipman is probably late 19-teens, maybe early 20s. I have a 1921 Jones & Shipman catalogue, and the drills are very similar looking, but the base plate is slightly different. This one's got a solid base plate, which I think is probably an earlier thing. However, I don't know. It is Morse taper 4, which is quite handy. I had another 20-inch model which didn't have power feed. It just had an ordinary sort of dog clutched lever quill hand feed, very basic drill, and that was a Morse taper 3. So getting this one was definitely an upgrade. Now, this is my Denby horizontal milling machine. Again, probably about the same age as the Jones & Shipman, and this has had a complete rebuild, everything except scraping the ways, because it's more than accurate enough as it is, and that's not a road that I have yet ventured down, and perhaps never will. This also has its original countershaft with the correct hangers. These are they're like ring oilers, but instead of a ring it's a chain, so there's a small sump in the bearing and a chain which drapes over the shaft, and as the shaft spins, the chain picks up oil and deposits it on top of the shaft. Quite clever little things. Interesting looking hangers. I'm not sure whether they're my favourite, but they are original to the machine, so they've got to stay. Again, basic shifter lever there to turn the machine on and off. Now this mill is very interesting in that it is extremely complete with a lot of tickable accessories from the maker. So it does have the universal table with the graduated angles on it. So very useful for helical gear cutting, etc. Something I've not yet attempted but would like to. Fairly simple to set up with a powered dividing head, which I do have, and a gear set up on the end of the table. Does have its original coolant system as well, so we've got the original cast iron coolant tank, which looks like it needs a clean. Simple belt driven power feed. I have 2 belts for the power feed, one slightly shorter than this so I can have an open belt. So depending on which way I want to feed, I just change the belts. One's open, one's crossed. Simple way of changing the direction. The pump on it is original and was rebuilt by myself. That works. I've yet to set up a drive for it so I can actually use it. The plan is to drive it from the countershaft that pulley up there, and I'll probably have a second countershaft somewhere over here to drive the pump, and that will have a separate clutch on it so it can be disengaged. Handy cupboard. Overall, really nice machine. I do have the extra supports as well, so can be extremely rigid. They clamp to the knee, and then those bars tighten up against the overarm support. In terms of work I had to do to it, it's had a good general clean paint. Obviously, I've re-scraped in the conical bearings, taper bearings, and I've made a brand new feed screw for the cross slide, if you like. So main reason being it was very slack. There was quite a lot of play in it. It had done quite a bit of work, and also someone had twatted it on the end of the handle, I expect, and it was severely bent. So I thought, well, let's have a crack at making a new one. And that was all done on the Pratt, which leads me nicely on to this lathe. Obviously a lot bigger than the Drummond and Victorian. It was built in Halifax in the 1890s. Pratt opened their London office in 1892, so I know that it's at least newer than that, and they became limited as well later on in that decade, so I'm positive it was in the mid 1890s. Just a nice example really of a late Victorian lathe. No bells and whistles, not very technologically advanced for its day, just a workhorse. I can get 6 feet between centres, and it will swing whatever that is, about 3 feet, I can't remember. So that's with the gap out at the moment, and the gap is an extra section of bed which will slot in here and can be removed to swing extra diameters. This is a drive pulley I'm working on currently for a customer. It needs boring out to 3 inches from its current 2.5, and then a new keyway cutting, which will probably be done over on the Redmond here, which is the next machine in line on this kind of older side of the shop. Now, this was built around 1900 and is of course a travelling head shaper. Again, I've done an entire video on this, so go and have a look at that. That is driven directly from the main shaft, from this very oily pulley, which is annoyingly just overhanging the bearing there, so it's getting covered in oil and flicking it all over the place. That needs changing. I can't move it any further that way, but I can move it over here somewhere out the way on this dry spot, but it does mean I need a new countershaft for the Redmond shaper. So I hope you enjoyed that little walk around. What started out for me as a need for some simple machines cheaply for my blacksmithing business has turned into a full-on living history project to build the kind of machine shop that you might find in a rural setting in Britain around the year 1900 to 1915, 1920. So those of you who know me, you know that's no surprise, because I did exactly the same thing for quite a number of years in the 15th century. All I've done is move forward a few hundred years, and now engineering has been invented and steam power, which is crucial, hold that thought,